Hello everyone, this is Team 7 Deep Language. So this is our final report for our question answering project in natural language processing. First, let's talk about our question generation module. We have some module that is used for this part. First, we have the pre-processing unit and we annotate the sentences. We use information extraction and co-reference resolution to extract some relation tuples from the sentences, and then we generate the questions and fine-tune them. We use the following libraries to do these tasks. Stanford Core NLP, NLTK, and WordNet. First, we took another sentences. We broke an raw text article into sentences, and we tokenize this as input for the next step. Secondly, we do the annotation. We use NLP algorithms to do pause tagging, name entity recognition, and the relation extraction based on different entities, and these are also applied for different questions. So first we have John lived in Boston because we have the pause tagging and parsing trees. And then we have the finally relation tuple stored in our database. And then we have the questions we can generate. We use the relation extracted to generate questions of three types. First is factorial questions. Then is WH questions, which is when, what, who, what, and why. Then we fine-tune the questions. We resolve the core reference, so the pronouns in the sentences are replaced by the true entities that noun was referred to, and use WordNet to replace and expand some sentences. Also, we filter out too short and long unreasonable sentences. The second is our question answering module. We have first retrieval-based answer candidate sentence selection based on Apache Solr, and we have the predicate form transformation function. Also, for binary question, that is factorial question, we have the algorithm called binary question keyword occurrence answering algorithm to answer the binary questions. For WH questions, we have n-gram tiling statistical answer extraction to do the answer free extraction from the sentences that is returned by our information retrieval search engine. Finally, we also incorporated dependency alignment-based answer extraction. First, our candidate sentence retrieval system is to first index the sentences as documents into the system, and we fire our query to the Solr search engine. The Solr will return 10 sentences that is candidate and statistically related with the query. For predicate transformation, this is the answer template we want to form for our final answer. We can see that the question can somehow be aligned to the predicate form of itself, basically the answer. So we can have who is the President of the United States. We can transform into the President of the United States is what. So we can fill that blank later with our answer extraction algorithm. So this is our answer is one of our answer extraction algorithm for WH questions. It's called n-gram tiling. First, we generate n-gram from the candidate sentences the search engine returned, and we apply some filters to remove some irrelevant words like stop words, negation, and query words like what, how, why. Further, for different questions, we can use question-specific filter such as the dependency filter, noun phrase filter, verb phrase filter, location, person, time to do further filtering. And this is alignment-based dependency extraction we have talked about. So we use dependency parsing of the query sentence to focus on which kind of part does the query want to know syntactically. So we search in the candidate sentences which which component of these n-grams best fit the syntactical positions. Like here we have who won the FMVP of NBA last year. So we have the verb, and we have the verb win that is subject with who and with an object this FMVP. So we can find the alignment of this relation tuple in the candidate sentences, that is James. And combination, first we do scoring using the unigram. Based on TF-IDF, we sort the n-grams based on the scoring with respect to the query. So finally, we have the answer phrases n-grams we want to fill in the answer template, which is highly relevant to our query. We get the answers here. Then for binary question and also factorial questions, we have an algorithm called binary question keyword occurrence answering. We first remove the keywords from the query, we get the keywords, and we iteratively search the keywords in the parsed top candidate sentence. So we'll answer yes to this question if all the keywords are found, or some keywords, or at least one keyword are missing, or we detect negation in the top candidate sentences. So on the whole, this is our whole answering pipeline. First, we have the question, we'll do initial retrieval, and we'll classify the question into WH question and binary questions. For binary question, we have binary keywords occurrence answering. And for WH question, we have n-gram and dependency tiling. We produce the answer phrase, we combine with the answer template from the predicate form. Finally, we have the answer. So this is our report for our NLP project. Thank you.